whose primary purpose is to assist the aerospace industry in scaling up. JMA is an evangelist for aerospace industry, especially the drone ecosystems, and strive to link the dots to complete the picture. JMA has worked tirelessly to raise awareness, provide infrastructure support, test site access, provide a skilled aerospace workforce, provide business solution, trained students for Industry 4.0, and foster industrial academia collaboration. JMA so far has conducted more than 200 workshops, professional talks, webinars, and seminars in numerous top institutions, colleges, and organizations to help give an insight into the industrial working of drone and aerospace sector. JMA has currently trained 61 drone pilots so far, and all of them have been successfully placed in top drone companies pan-India. Welcome, Mr. Leo Peters, once again.
Thank you so much for that introduction.
I would also like to welcome the team of Jain Aerospace Limited. Extend very warm welcome to all participants who are assembled virtually. I would now like to touch upon few standard instructions to be followed by the participants. Mute your audio and video to avoid disturbance during the session. In case of query, do drop them in the chat box or use the facility of raising hands. Please leave your contact details in the chat box. That will help us to invite for upcoming programs. Topic for the day is Introduction to Drone Technology. Let us not waste time further or delay the time further. Over to you, Mr. Peters.
Thank you so much for that introduction and warm welcome. It's indeed a pleasure to be talking on my most loved subject. My most loved subject, that is drones. Just a brief to everyone. We've disabled chat for some time. You'll be able to re-enable, you'll be able to type it again during the break or after the session, after I speak and during the question and answer session. Request everyone to be on mute, as I know we are all at home and then there are kids and everybody. So this will help not lose track of what I'm telling, and then my flow of thought doesn't get disrupted. So that being said, we will dive in. So I will place the context of what we will be speaking. Next slide, please. So we will be covering in depth and detail the entire drone segment. Most of our understanding would have been limited to what we've seen drones in weddings or in other places. But then today drones have more than 200 applications. I am unfortunately, due to the time constraint, I am not touching upon all the 200, but then we will be seeing the 35 most used application with a large business case that will help create more drone companies as well as entrepreneurs, and then people will be able to choose a career in the drone industry. So we will have an introduction. We will look at history, when drones started. We'll look at the global drone market, the Indian drone market, Indian rules and regulations, and then the innumerable applications that exist. And let's look at the career opportunities for budding graduates, and also the business opportunities for aspiring entrepreneurs and existing industrialists and business person. Then we have a brief talk about what we do in detail at JMA, and the most interesting program that I am looking forward to in the coming months is the Flight 100 program, where we will be mentoring 100 entrepreneurs. So without much further ado, let's dive into the topic. Please, if this is going to be a very interesting thing, you can consider it as a movie, so you can grab your cup of coffee or popcorn and then sit. And please also make sure you have a note to make note of the questions, so that you will be able to ask them at the end. So what are drones? is a very crucial question that we need to answer. Everybody has this conception that the aircraft with 4 rotors flying is drones. Next slide. Let's take a look at what drones are. So a drone is basically any unmanned vehicle, right? It can be an aerial based vehicle, it can be a ground based vehicle, or it can be an aquatic based vehicle. You can see the aerial based vehicles are called unmanned aerial vehicles or UAVs, and ground based vehicles are called UGVs or rovers, and aquatic based vehicles are called unmanned water vehicles or unmanned aquatic vehicles, and you also have the other segment of unmanned submersibles. So these are all drones put together. And I specialize, or my passion lies in UAV. I've always been fascinated about flying, and so that is the segment that we deal with. And a UAV or a UAS, unmanned aircraft system, in its entirety contains the flying vehicle. You have a command and control link. It can be a satellite satcom link or a radio communication link. And then you have the ground station setup, which includes the pilot. All this put together forms the drone unmanned aerial system. And today drones have multiple of applications, and it is really mind boggling to be witnessing them on a day-to-day basis. I am not kidding. The innovations that happen in drone tech are on a day-to-day basis, and somebody imagined they could put a drone on Mars, and then we are doing, I think, the 7th flight right now on the Martian surface. So I have this one famous saying: drone application is limited by human imagination. Whatever you could imagine that can be done through a drone, it is possible to be done. There is no bias, there is no prejudice. Drones can execute whatever you think of. If you think you can build a drone that can deliver your coffee from the kitchen to your dining room or your reading room, is possible. It's just that it needs to make business sense, right? But then it's been a fascinating journey for me in the last 10 years, right from when I started my engineering program, and then when I built my first unmanned aircraft when I was in college, way back in 2010. And from then onwards, I've always been looking to the sky. And today we will be talking about that, and then why I say my passion, hobby, and business is drones, and then why it has always kept me and my team captivated for such long times. Next slide. So these are the classification of drones. The most common one that you would have seen is a multi-rotor, but then all of the other variants exist. The one that really started off was the fixed wing. It looks like an aeroplane, right? And it can fly for a longer duration and cover a longer distance. So that's the beauty of the fixed wing. Then we have the rotary wing division. In that, we start with the helicopter or the heli drone. It looks like a helicopter, and the biggest advantage is it can take off and land vertically, what we call VTOL. And also it has greater maneuverability. It can hover at a location. So in this segment, because the power to weight ratio is very great, the helicopter can fly upside down as well. So that is also possible. So all of that can be done with the heli, and it has been used for multiple applications, as we will see down the line. And then came the multi-rotor. The multi-rotor is one of the most stablest drone platform, and the beauty about it is you could put multiple amounts of payload. You could carry larger payloads with a smaller drone size because of the multiple thrust producing, say, parts or components in the drone. And always remember, apart from the tricopter, multi-rotors always have even number of rotors. And the fixed wing, the single rotor, and the multi-rotor form the basic block of the unmanned aerial vehicle segment. And then we have the other variants. Then came the hybrid VTOL. Now, hybrid VTOL is a fixed wing drone with and a multi-rotor combined together. What it does is it helps take off and land vertically. For a fixed wing, you need a runway or you need a large patch of clear land for it to take off or land. So that problem is there. For a multi-rotary or a rotary wing drone, you don't need that. So the hybrid VTOL took that, but then multi-rotors and single rotor do not have a long range or high endurance. It captured that part of the benefit from the fixed wing, and then that became the hybrid VTOL. Now, apart from this, you would have seen this bird in the movie Uri, right? So this is an ornithopter, first envisioned by Leonardo da Vinci. And today, this has been used in multiple places. Now, in industrialized nations where corporate farming has already come into existence and where corporations hold thousands of hectares of single land holding, scarecrows don't basically do the work of scaring away the birds. So they have this flying around and scaring away birds that might potentially destroy crops. Now, this is designed after a predator bird. This is a peregrine falcon. So other birds that are generally herbivorous or generally depend on small worms and all of that, they're always the prey. So that way, this also helps scare them away. Another beautiful application of the ornithopter is that it is being deployed at airports to scare away birds. That way, you can stop a bird strike and save a lot of money by not getting the aircraft damaged. And then we have the aerostat, traditional balloon with helium. The best part about the aerostat is that it can be in the air for a very long duration of time. And if you say, let's say, border patrolling or an event that is going to be like a test cricket or even a one-day cricket that needs to be videographed from the air continuously without having to change the power unit, aerostat does the job. So that is also another drone. So the six of this forms the basic block, but you have other variants as well. You have the syncopter, you have drones. So they're all different variants, but this is the basic building block of the types of drones that exist out there. Next slide, please. So let's take a look at the history. And so all of you might be wondering when drones really started, right? So even I did do that, but then when I found it, I was shocked. Next slide. So the first drones or the concept of drones were used in 1849. So the Austrian army used air balloons filled with bombs to attack Venice. So it would basically, they would fly it over on Venice and drop the bombs. So this is how it worked. They used a rope mechanism to release. So that was the oldest recorded unmanned aircraft having a particular mission. Now, another thing with that was, as the story goes, the balloons actually came back over on the Austrians, and then that was a mess. But then that's how it started. Next, both the world wars really contributed to the development of the aerospace industry in its own, and also the drone industry, because better aircrafts came out, better aerodynamics came out, better propulsion systems came out, jet engine came out during the Second World War. And similarly, drones also came out. Now, the first would be aerial targets for anti-aircraft guns. So the Ruston Proctor was built in the United Kingdom by Mr. Archibald Doe, and that was the first controlled aerial target that was there. And later, the US Navy in 1937 started the testing of the Curtiss N2C2 drone. And that is where they started to understand the expanse of applications that can be achieved with drones. And in 1943, Germany started the Fritz X. It's basically a bomb, but then you could control it through a radio control device, and the controller weighed more than a ton. So you remember the old days of vacuum tubes and all of that. And that had a specific mission as well. So that's how it all started. Next slide. And in 1960, Vietnam War also saw the use of stealth drones and target drones. 1970 actually is what our understanding or our conceptualization of a military drone, as we see it today, came into being. Israel built the Mastiff UAV and the IAS Scout. So these two started the era of armed military intervention through drones, as well as ISR activities, that is intelligence, surveillance, and reconnaissance activities. And in 1982, we also see another event where Israel outwits and Soviet anti-aircraft technology using swarm of unmanned aircraft. So swarming concept is there already by 1982 in Syria. And then we see in 1986, we see the reconnaissance drone, the RQ-2 Pioneer, a joint project by the US and the Israeli governments that again become a medium-sized reconnaissance drone. And then the famous Predator came into being, which occupied most of the screen space in Hollywood war movies, and whose image has been imprinted in our minds as the military drone that takes out targets, where pilots sit on another country and the drone is flying in another country. So that's the beautiful history of drones. Majorly started with military, as with all technologies. And then today we are seeing commercial usage crossing military usage itself. Next slide. So let's look at the global drone market. Next slide. So interestingly, one thing that happened is the pandemic actually accelerated drone usage. So I remember, so when the first lockdown happened, I was working with the Bangalore City Police, and then we built a drone along with General Aeronautics with a megaphone attached to it, and then we were using that drone to do public announcement. And then drone-based sanitization came into picture. A lot of companies started using radiometric thermal cameras to detect temperature of people on the road or in containment zones. Then we had drones for with AI-backed capability to understand if there's social distancing, if people are wearing masks, to identify that in larger areas. And we also had few issues that came with wildlife management, where poaching and forest fires became an issue. So basically, and drone delivery, of course, how could we forget that? So basically, the pandemic actually accelerated the entire drone industry and its usage. And governments became the largest client for usage of drones all over the planet. And I think most of the countries, maybe some few exceptions, but most of the countries use drones to help during the lockdown. And we see a very good compounding annual growth rate that is happening. And then the market is now potential to reach 100 billion USD by 2027, with large scale purchases happening both in the military as well as the commercial segment. And Asia has been one of the largest manufacturers of commercial drones, as well as now going into military segment, and also the largest market for these drones. Next slide. The Indian drone market has not been an exception. India is the largest market for drones in Asia, and it has been consuming drones on a very enormous scale. When I remember in 2018, if I am right, or 19 beginning, they introduced, or 2018 beginning, I'm not really sure about the date. They introduced the DAN concept of the drone acknowledgement and the owner acknowledgement number concept, where you could register your drone freely, so that the government gets a tally. More than 20,000 drones were registered in India. And I know for a fact that everybody did not register, thinking that the government might confiscate, because drones became legal in this country only after the first. So that way, it has been a phenomenal thing, and the market has been growing widely. Next slide. So the Indian drone market also has a 40% compounding annual growth rate, with the largest purchasers being the government themselves. We are looking at 800 million USD market by the end of 2025. So because of two major programs that got added after this data was generated, and that way this is going to become a very large use case. One of that largest program being the NSUAS project with the Indian Navy, where they're looking to buy 50 drones for the drones to be deployed from the Navy ships, and that is going to be almost a 3,500 crore project. And apart from that, we're buying another, I think we will see in the next slide, largest orders for the drone segment also got placed in India with Idea Forge. Next slide. So 3 billion USD procured 30 MQ-9 Reaper drones. We initially bought 3 on lease from General Atomics, and then now we're looking to procure 30. And one of the largest drone contracts in the country got signed with Idea Forge, where they are procuring hundreds systems at about 140 crores, and that is the size of military contracts in the drone segment, where under the Atmanirbhar program, the armed forces are looking to buy from Indian vendors. So our military spending is what is boosting the drone segment as well.
Technical training, and human resource. It's my privilege to welcome Mr. Leo Peter Charles today's session. He is an avid aero modeler and a drone platform evangelist. He has a bachelor degree in aeronautic engineering from MVJ College of Engineering. He is also a serial entrepreneur who has the experience of having startups in the IT, hobby retail, and UAV training industry. He has trained more than 5,000 students in aero modeling in his career spanning 6 years now. He has also had the opportunity of training 100 academic institutions like VIT Bhopal, MVJ College of Engineering, Agni College of Technology. He is also an aerospace consultant for many companies. Mr. Peter completed his journey as a CEO of Garuda Aerospace Private Limited recently.